Good morning, class.
Good morning, sir.
Good morning, sir.
Please, how
Morning,
are you
sir.
doing?
Yes, sir.
By God's grace, you are fine.
We thank God. I'm also good by God's grace.
We
I'm,
thank
I'm
God.
also good by God's grace. Please, today I'll close early. Latest by 8:30, I'll end the class. But if I'm praying that um, we can finish earlier. But latest by 8:30, I'll end the class. Please, how that's okay.
Yes, sir.
Thank you for the permission
Yes,
or granting me
yes,
this
sir.
opportunity. Okay. So last meeting, can someone tell us what we did? Can someone tell us what we did in our last meeting? Can someone talk to us? No, sir. Hello? Hey, if you will not respond, what did we do last week?
Sir, please, good morning.
Good morning, my dear.
Please, last week we did null hypothesis and alternative hypothesis.
So last week we learned how to state the hypothesis and also how to um, reject it or accept it based on the probability rule, right?
Yes, sir.
So let's make a recap. So actually, what we learned was that I think I remember we learned that we have what we call the research hypothesis, and then from the research hypothesis, you can get your statistical hypothesis. So the research hypothesis is what motivates the researcher to go in and investigate whatever he or she wants to do, right? And from that, you can state your statistical hypothesis, which is stated in such a way that you will be able to measure. And so we say that the null hypothesis will always tell you that there's no defect, there's no change, there's no association, there's no impact, and there's no relationship. Okay. And then we say that the alternative, which is opposite of the null, will always tell that there is a change, there's some difference, there's some association in there, there's an impact, there's effect, there's an increment, there's this, there's that, this, okay. And then from there, we learned that you can accept it is always the null hypothesis that we test. And so we either accept it or reject it. Okay. That is your statistical decision. So after making your statistical decision, then you can draw a conclusion with regards to the what you did. Either you accepted or you rejected it. Okay. So we learned that based on the probability rule, you can accept or reject the null hypothesis. And then we said that whenever the probability value is greater than alpha, which is the significance level, we always do what? We always accept the null hypothesis whenever it's greater. And then on the other hand, if it is less than that, then you are going to reject it. And then we said that whenever you reject a null hypothesis, whenever I reject a null hypothesis, then it implies that you have that's what we call it is statistically significant. Statistically significant. Okay. And so if you accept it, then you say it is not statistically significant. Okay. So basically, I think that is what we did in a summary. I hope I have not missed anything, right? I hope I've not missed anything for a recap. Good, good, good. Okay, so now let's start today's class. Okay, please can you guys see the screen?
Yes.
Yes, sir.
Okay. So basically this is the steps that we go through to get our test being done. So I remember I said that we've gotten to this side. We learned what data is, the types of data, whatever, and then we've also learned how to state the hypothesis. And so now we are this side. We are going to select the test statistic. After stating your hypothesis based on the scenario or based on the problem at hand, then you have to choose the test statistic that you are going to use. It's like you guys, when you know that when you diagnose someone, then you can prescribe the right medicine for that, right? So now that you know your data and you've been able to state your null and the alternative hypothesis, then you can now come up with your selected test statistic. What fits that scenario? What can solve that problem for you? And after that, then based on that one, there is a way of calculating its test statistic. You need to calculate it. So when you calculate it, then based on the probability value, you can take your decision either to accept or reject it. Okay. Either you accept or reject it. Okay. Then you can draw your conclusion. Okay, then you can draw a conclusion. So basically, we are here. So that's what we are going to do today. So what we are doing today is what we call the paired sample t-test or the dependent t-test. It is also referred to as dependent t-test, paired t-test, or matched t-test. Some also refer to as correlated t-test. Okay, so that is what we are going to do. And this paired t-test, please keep in mind, you can only apply it when the problem at hand is pre and post scenario, before and after scenario, or before and after an intervention. That is where you can apply your paired t-test. If you have a problem where you are observing or you want to compare the means or the averages between before observations and after observations. That before there is an intervention, the observation that you obtained, and then after that intervention, the observations or the records or the data that you obtained, you want to compare them. That is where you can apply your uh, pair t-test. So let's assume that you are in a facility, and then probably you want to check the they've increased your salary. Let me put it that way. They've increased your salary, or let's say you've reduced the charges at your facility. So you want to compare if there's any significant difference between the number of patients or the patients that are coming to your facility and that of after the reduction. Another example is let's assume there's a drug. Then that drug, you want to know if the drug is having impact on, let's say, pain level. You can only compare, you can only know that the drug is having impact when you compare the pain level before you gave her the drug and after you gave her the drug. And so this one, you always see that the recordings will be coming from the same individual or the same person. The recording that you are going to compare, you see that the before data or before information about that person or item or whatever is there. And then the after two, you get it there. So that's why we call dependent t-test, because you will see that you'll be dealing with the same individual or the same person or the same item. Okay. So that is what we call the the per t-test. And you can apply it when your sample size is less than 30. It's less than 30. Okay. So this is the formula. I think I mentioned last some time ago that for the past 3 years, or I think 2 years, I've been providing my students with formulas. So the formula shouldn't be an issue. I'm certain that one I can say it's 100% that I'll provide you with formulas for your exam sake. For exam sake, I provide formulas for students. Okay. But just get the concept. It doesn't mean because when I give you the formulas, I'm not going to put the formulas just beside the questions. It will be on a different sheet. So if you don't know what you have to use, then it's up to you. Okay. But I'll give the formulas for you. So that's why I keep telling you that get the concept, get the knowledge. Okay, so now let's continue. So as I said that this per-t test, it is used to check before and after. So let's assume that I have before here, B, and after here. And then we are comparing it. Do you get it? So if you are comparing it, definitely the null hypothesis. The null hypothesis will always tell us that there's no difference in whatever we are doing. In the observation that we are doing, there's no difference. They are the same. There's no change in whatever you are doing. That means that, let's say, the pain level before the drug and the pain level after the drug are the same. So if that being the case, then we can say that B is equal to A. B is equal to A. That means that the now will tell that there's no change. The observation that you are having in B is the same thing as A. So if B is equal to A, then I can say that if I want to find the difference, let's assume the values, the average. Don't forget we are comparing means. So let's assume that the mean for B, this is just assumption. The mean or the average for the B observation, that is the before observation, let's assume that is 4. And then the average for the A is what? Also 4. That's what the now will tell you. And so it means that if I find a difference, it is 0. I hope you agree with me. If I find a difference, 4 minus 4 will give me 0. And so it tells you that there's no difference in their means. So if there's no difference in their mean, then I can say that S bar is equal to 0. The mean is equal to 0. That implies that there's no difference in their mean. Their averages are the same. There's no change. And that is what the now always tell you. And that is the reason why the formula, we have 0 here. Because always the per-t test, the emphasis is on the difference. The difference is the most important thing that we are looking for. And so we look out for the difference. So if we assume that the now is always, the now is telling us that there's no difference, there's no association, there's no impact. And so here we are comparing means. So we are saying that there's no change. Their means are the same. So definitely 0. So this is the formula. So this guy, I know you know this guy. This is the mean. This guy is the standard deviation. And this is the sample size. So the mean minus 0 will give us the mean itself. Okay. The mean divided by the standard deviation. And then the standard deviation also divided by n. And this is the test statistic formula. So if you remember, let me clear everything. If you remember the chart that I showed, this good. This side, you need to calculate your test statistic. So the formula to calculate the test statistic is what we have here. T is equal to S bar divided by X. You see, this is X, the mean, divided by the standard deviation, and the standard deviation also divided by square root of n. Okay. Please, any question on the formula before I move on? Please, do you have any question? If you have any question on the formula or any questions so far, what I've discussed with you, if you have any questions so far, please talk to me. Patricia Frimpong. Hurry up, please, hurry up.
Okay. So please, with the T, does it mean you can either use the mean minus 0, like the first one, or the second one?
It's the
Because
same
I'm
thing.
seeing equal to. You can
It's the
either
same
use
thing.
any of them, right?
My
Okay.
dear, it's the same thing. Don't bother yourself.
Okay. I thought it's
This
a full formula.
yeah,
I thought
this is
both
the formula
formula.
because this is 0. One, this is 0. It gives you this. It gives you that. So you don't need to bother yourself and come and use this one. Okay.
Okay. Okay. Thank you.
Bismarck, please hurry up. Bismarck, please talk to me.
Yeah, please, I want to find out whether the main use there is it for the first, is it for the before or
No,
the
no,
after?
no, 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 no. Just understand the concept of mean. As we move
Okay.
on, we are now going to calculate it. I just want to know that it is the mean. So how to calculate the mean and whatever, that's what we are going to do next. Okay.
Okay.
Okay, Patricia Frimpong, please talk to me. Your hand is still up.
Hey, sorry. Wait.
Okay.
Sorry,
Irene.
sir.
Irene.
Yes, sir. Sir, please, I joined and then I got logged up. So I don't know if the question I'm about to ask has been answered. Sir, please, you see in previous formulas for looking for the sample size and then the population size, the standard of deviation, we used P as that, and then here we are using S. So I want to know
I'm
why
not
we are using.
please listen to what I said. I didn't say standard of deviation. I said standard deviation. Standard
Oh, okay,
deviation.
okay, thank you.
Okay. Yes. Okay, so now I want you guys to look at the scenario here, and I want you to analyze it if we can apply our PERT test. Don't forget that we can apply the PERT test when it is post or pre. We want to compare pre and post or post and pre. So I want you to analyze it for me. Please analyze it. Please analyze it and let's see. I want you to, if you think we can use it, if you think we can use, please raise up your hand and then talk to me. Genevieve Osei Kisi. Unmute
Hello,
yourself.
sir.
Yes.
Good morning, sir.
Good morning.
Please, I'm trying. I can say we can use it because first the blood pressure was taken and then they rested for 5 minutes and then there was 2 mils of 0.5 solution of hypotonic drug was given. So there was something given. So they checked again. So there can either be a difference between the
Good.
first one and the second
Good.
one. So I think
Good.
we can use it.
Good. 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 So we can apply a PERT test. So you see that there is an observation before and then there is an observation after. And you see that these observations are coming from the same 9 individuals. So we are comparing the observations of these 9 individuals. Okay. So here, you should know that N is what? Who can tell me N based on this statement? What is the value of N? N is equal to what? This one, you can unmute yourself and talk. You don't need to raise up your hand.
9.
Oh, Hannah.
9. It's
9.
9.
Good, good. That's fine. That's fine. So N is 9. Thank you. Thank you. So N is 9. Good. So now, the first thing is to state your null and alternative. I'm not going to state it. I'm not going to state it because I know you will be able to state it. But note that the first is to state your null and then alternative. Okay, so the null can tell that the drug is not causing hypotensive effect. And then the alternative will tell that the drug is causing hypotensive effect. That's it. That can be the null. Okay. So now, this is the data. Please take your time and look at it. What I'm going to do, take your time. And I'm leaving you. Please get yourself calculators there. Okay. So now this is the data. Because we've already seen that they recorded before that hypotensive drag and after they recorded it. Good. So in real life or in any question, you are always likely to get this data set, the before and after. You will not get the differences. The differences, if you are fortunate and you have it, good, you are good to go. But in real life or in real sense, most cases you will not get the differences. This is the raw data, the before and after. That is the raw data. That is the raw data. So then you will need to compute the differences. You, as a researcher, will need to compute the differences. And please keep in mind, the differences, you can either subtract before from after. You can either subtract before from after, or you subtract after from before. You can go by any direction. You subtract before from after, or after from before. Okay? The only difference in your answer will be that one will get negative answer and the other will get a positive answer. But that doesn't affect your conclusion because we always take the absolute value. The absolute value. Absolute value here means that the number without any sign. We always take the absolute value. Okay, so it doesn't matter. So if you look here, are we subtracting before from after or after from before? Look at this one. The differences. Are we subtracting before from after or after from before?
So before from after.
Good. Good. So then let's do it. Please, I'm going to call
After from
Juliet.
before.
So now let's okay, Bismarck is here. Bismarck, let's do it. Okay. Class, please. I'm going to let Bismarck talk one after the other. Okay. So that things will be simple for us. So Bismarck, let's find the differences. Okay. So the difference, the first one is going to be what? 122 minus 120.
122. Yes.
And that will give us what?
That gives us 2.
Good. Now the next
2.
one, let's continue.
121 minus 118, that gives us 3.
Good. Next.
120 minus 115, that gives us 5.
Good. Next.
126. Sorry, 115 minus 110, that gives us 5.
Good. So class, we are going to skip and move to the last one. Okay. We are going to skip.
128 minus 125, that gives us 3.
Good.
Yes.
So then, if you do it correctly, you should have these differences. You should have these differences. And if you remember, someone asked, which of the means are you going to use? Good. So now, the moment you get your differences, you don't need these guys. You don't need the before and after. You don't need them. You don't need them anymore. All what you are going to do, or all your concentration now, is on the differences. Now, these are the guys that you are going to deal with. So based on these observations or these guys, you are now going to calculate your T, which is equal to S bar over the S divided by square root of N. Okay, so to make things simple for us, I'm going to add D to the S bar so that you know that we are going to compute the mean from the differences. And I'm going to add the D to standard deviation so that you know that this standard deviation too is coming from the differences. I hope it's clear. Is that okay, class, please?
Sir, please come again.
I'm saying that the formula is giving us the mean divided by the standard deviation. Okay? The mean divided by the standard deviation. But I have added D subscript d to the mean here, so that you know that this mean is coming from the differences. It's coming from the differences. And this standard deviation here too is also coming from the differences. But the formula still remains the same as the mean divided by the standard deviation divided by square root of n. Is that okay?
Yes, sir.
Good. Okay, so now let's I hope you remember how to calculate the any Bismarck, are you there? Okay. So the mean is equal to summation what? X over n. Do you remember this formula, class?
Yes, please.
Good, good. Summation x over n. And then the standard deviation, let me pick different color. Let me pick color blue. So the standard deviation x is also equal to the square root of summation x minus the s bar all squared. There's a square here, divided by n minus 1. Do you remember this formula too?
Yes. So the x, the second x is it x bar or x?
S bar. Thank you. S bar. There's S bar there. Do you remember this formula?
Yes, sir. That's standard deviation.
Standard deviation. Good. So we are going to do it one after the other. Okay. So we are going to do it one after the other. So I'm going to clear everything. Then we do it step by step. Please do it whilst you are there. Try it. So we need to find summation x. Summation x, which is equal to this plus that, plus that, plus that, plus that, plus that, plus that, plus that. You are going to add all the differences, and that will give you 27. Please try it. Are you getting the same value?
Yes, sir.
Yes, sir. Yes, sir.
Good. So then it means that our summation x is equal to 27. And then n is what?
9.
9.
9.
So then we can divide it by what? 9. So it means that our mean is equal to what?
Right.
Good. I hope you are getting this. You guys are getting it? Please, are you getting the same answers? If you had the same answer, please type 1 for me. Let me just go and check mine. Please type 1 for me. Type 1 for me. If you are getting it, please type 1 for me. Oh, good. That's fine. Okay, let's continue, please. Let's continue. So now that we know our mean, it means that from the formula, let me write the formula here. T, which is equal to the mean divided by standard deviation by a square root of n. It means that this guy is now what? 3. So we are left with this guy, and then we know this to be 9. So we are just left with the standard deviation. I hope you are all in agreement with me. We just need a standard deviation. That's what we need now. Right?
Yes, please.
Okay, so please, I'm going to clear it, then we move to the next slide. Okay. Okay, so Bismarck, Bismarck, please, can you see the two slides on your screen, please?
The 2 pages.
I mean, yeah, the 2 pages.
Yes, please.
Thank you. So now, let's find the standard deviation. So the standard deviation formula, as you can see, it is here, right? So what we need to calculate is summation x minus the s bar all squared. That's what we need. So now I can write this thing as, the top side or the numerator of the formula. So I can write this thing as, if you agree with me, x minus 3 all squared. Do you see that?
Yes.
Yes, please.
Good. So if that be the case, then it means that we are going to subtract 3 from all the x's. And what are these x's? The differences that we found. So Bismarck, let's do it one after the other. Let's put the first s value here. What is it?
2 minus 3.
And that's what we have here. And that will give us what?
Negative 1 squared, giving us 1.
Good. So we have 1 here. I hope you guys can see it. Let me clear the screen so that I can take it. We have 1 here. Now the next s value is what?
3. So 3
Good.
minus 3.
3
Giving
minus
us
3 is here.
0
And that will give
squared.
us what?
That is 0.
0. Next,
5 minus 3 all squared, giving us 2 squared. That is 4.
good. Next,
Another 5 minus 3 all squared, 2 squared. That is 4. 4 minus 3 all squared, giving us 1 squared. That is 1. 0 minus 3 all squared, giving us negative 3 all squared. That is 9. 4 minus 3 all squared, giving us 1 squared. That is 1. 1 minus 3 all squared, giving us negative 2 squared. That is 4. And 3 minus 3 all squared, giving us 0 squared. That is 0.
okay. So any question? Bismarck, ask your people. You taught them. Right now you taught them. So ask your people if they have question. If they have question, then we help them. Any question on that? What Bismarck did? Any question? I can see one hand up. Bismarck, get ready. Or say Moses.
Yes, sir. So
What's your
my
problem?
question is about the mean. No? You see, we calculate the sum of the numbers where we get 27. So I was thinking that if like we subtract 3 minus 27, then we get 24. And
No,
then
no,
the
no, no,
20,
no, 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 no. There's no shortcut anywhere. Listen and
okay,
listen very well. Summation x minus x squared, okay, it's not the same thing as. This means that this is not the same thing. Look at this one. Summation x minus x squared. It's not the same thing as summation x minus the s bar squared. It's not the same thing. These things are two different things. This means that you sum all the x's. Whatever you get, you can now come and subtract the mean, then you square. Do you get it?
okay,
But this one means that you do the subtraction first, then you square before you sum.
okay,
Okay? Okay.
okay,
I knew it. Well, I knew it. I knew people would do that. That is not the same, please.
okay,
Okay.
thank you.
Okay. The next person, Conchi Beatrice.
Yeah, sir, can you please go over the computing again? I got lost at a point.
Please, we've computed from the mean to this place. Can you be specific for us?
So this one, just the one on the screen.
The one that okay, so Bismarck, can you
The standard deviation.
we've not completed a standard deviation. We are just working with the sum of squares, which is summation of the x minus the x bar all squared. That's what we are doing. Okay. Okay. So Bismarck, just take outside. Let's do it up to this side. Okay.
Okay, sir.
1, 2, 3, 4, 5. Then the rest she will just have to get it. Please, Bismarck, let's go.
So the mean is 3. So the first one is 2 minus 3 all squared, giving us negative 1 squared. That is 1.
1. Okay.
The next one is 3 minus 3 all squared, giving us 0 all squared. That is 0 squared. That is 0. 5 minus 3 all squared is 5 minus 3 is 2. So 2 squared is 4. Another 5 minus 3 is 2. 2 squared is 4. Yes.
Okay. My dear, are you okay now? What's her name? The lady who asked the question.
No, please.
So what's exactly the problem? Because we just repeated it. What exactly is the problem, please?
So I thought the X was 3,
Mm-hmm.
but you are using 2 here.
Which 2? We've not seen any 2 here.
The
Where?
first one.
Where?
The second step.
Uh-huh.
Summation
This
of
is
X minus X bar. You
so
use
tell me X. You tell me X. Tell me the S value.
the X is 3.
The S is not 3. That's where your problem is. These are the X's. The S's are the difference that we found. These are the X's. So now tell me the first X there.
2.
Good. So that is why Bismarck said 2. And what is the mean? The mean value?
The
S
mean
bar.
was 3.
Uh-huh. So that is why Bismarck said 2 minus 3 will give you minus 1. You square it, you had 1. That's why Bismarck said that.
Okay, so say the X, why did you choose 2 instead of any other number?
But can't you see that we've subtracted from all the numbers, not just 2? Can you see that we've subtracted it from all the numbers?
Yes.
So it's not a matter of choosing any other number. You have to do it for all the X's there. If we had 20, we would do it for all the 20 observations. If we had 15, all the 15 observations. Is that okay now?
So we are doing the first one. Okay, I get it. Thank you.
Okay. So Bismarck, now let's move on, Bismarck. So now that we found our squares, we can sum them, then we get a sum of squares. Okay. Get it? Okay, Bismarck, I think I just saw one hand here. Or saying I'm mistaken, please.
Sir, please, there is a question in the chat box. If you can attend to that for me. I think it's my question too. Thank
So
you.
talk to me here. Talk to me here. The chat, but I've not seen it. They are not, I have
Okay.
about 100 and something messages.
Okay.
Just
It
talk
said
to
in
me.
question like this, must you follow the same process to get your mean difference? That's, must you draw the table and add the mean difference, or can find the mean difference without drawing the table?
Which table?
Mean this table, the table on the screen right now.
No, the table. You see, this is the data. This is the data.
Okay.
This is the data. So this is always what is actually the figures that you get on the ground.
Okay.
So these differences, if you have a way of getting it, I don't care. But you just have to let us know how you got the differences. Just find the differences first, then you just do your you find your mean.
Okay. Okay. Thank you.
Okay, so Bismarck, I think we can move on, right?
Yes, please.
Okay. Please, if I've answered you, you can put your hand down, then we can move on, okay? And later on. Comfort Bar, ask your question. Bismarck, sorry, please, sorry, let's answer them, then we move on.
Sir, thank you. Let me use this to see if we can understand. I think some of our problems are where the X1 and the X2 is coming from. They said we have 9 patients and we checked their BPs. So the X1 and the X2, the X1 was the BPs that was first checked, and the X2 were the ones that was checked after medication was given. So these figures, I think some of them are thinking, if we by. We said we checked BP.
No.
Those numbers are the
It
BPs
means
that
that
were checked.
they are not following what we are doing, because you can
So
see
I
that
think
this
that's where
table,
some of the confusion is
showed
coming from.
we showed this table in the previous slide, and it is even the same, just that I just want to show these 2 pages. That's why I've zoomed in, okay, so that I can show these 2 pages. So if I zoom in again, you can see that it is there before injection X1, before, after. So it's not a matter of you picking it anywhere. I hope you are getting my point. That's the
Yes, sir.
problem.
Thank you very much.
Most of you guys, okay, anyway, that's okay. Thank you for that clarification. Let's move on. So Bismarck, I think we can continue now, right? So
Yes,
now
please.
Bismarck, let's add them. So it means we are adding everything, right? All the square that we had. Now let's add them. And what are we getting, Bismarck?
We are getting 24.
Good. So then it means that the square root of summation x minus the s bar squared this side over n minus 1. So this means that now we have the square root of 24, right? Because
Yes,
everything there is 24. And what is the n value?
9.
Hey, someone said p or 2.
9.
What is the value of n?
9.
9.
Please, it's 9.
9.
9.
Yes.
Good. So please let Bismarck continue from here. Otherwise, there will be some noise in the
So
class. So Bismarck, that is 9, right? So 9 minus 1 will give us what?
8.
8.
8. So that is why we have 24 divided by 8. So Bismarck tried. So 24 divided by 8 will give us what?
3.
24 divided by 3.
Oh, please let Bismarck respond. Please let Bismarck respond. Otherwise, if anybody keep responding, the class will be noisy, please. But you can also respond over there, but don't you can check it and verify it yourself over there. So Bismarck, 3 square root of 3 is what?
1.732.
Good, 1.73. I hope you guys can identify the square root on your calculators. That is not another thing that I should come and teach today. Good. So now that we've been able to find our standard deviation, now let me choose different color. Let me choose my red. Now we know T is equal to the S bar divided by the standard deviation divided by square root of n. So Bismarck, can we put the values inside? Let's put
Yes,
the
please. So
values of this.
T is
So
equal
this
to
is
3
okay.
divided by 1.73
Good.
divided by the square root of 9. Yes.
Good. So now this become your T statistic. So from here, you guys should try it. But I would advise you that you work this one first, the 1.73 divided by square root of 9. Whatever you get, then you can now come and divide that one by 3. I mean 3 by that one. Okay. So let me clear everything. Then you try it. Let me write it again. So this means that T is equal to 3 divided by 1.73 divided by square root of n. And I'm saying that, oh, this n, let me write the 9. And I'm saying that do your best to solve this one first. Whatever you get, then you can now come and divide 3 by that. Okay. So please try it before I show the solution. Try it. Bismarck, you can say your answer when you find your answer. You can say it, but the rest I'll ask them to type one if they got the same thing. So please try it, my sisters and brothers. Please try it.
Okay. So I'm getting 5.208. That's 5.21.
Oh, okay. 5.21.
Yes.
Okay, that's fine. So 5.21 or 5.18. Take your time.
Okay, I think
Because of the
it's for
approximation.
approximation. Yes.
Yeah. So let's give ourselves some few minutes and wait for our sisters and brothers to also try it. Okay, so please, Bismarck, I think I can put the answer there, right?
Yes, please.
Okay. Okay, so now this is the answer. I think I can zoom out. Uh-oh, I shouldn't have rotated it. Okay. Please, are you guys getting it? If you are getting the same answer as usual, just type 1 for me. Let's type 1.
So some of us had 5.2.
But it's the same thing. It's the same thing.
Okay.
Good. Now, good. Okay, that's fine. So now let's move on. Please, I'm going to explain this statement. Oh. Okay. So that statement, I'm giving you the reason why I played that statement in your slides. I'm believing God that by the grace of God, some or almost everybody here should be able to go and do his or her master's and probably the PhD. Okay, so I've put this one there so that at least when you move to the next level and probably you meet another lecturer who talks about the traditional method. Even though I've talked about the traditional method, and I said we are using the p-value method, which widely that's the most method that we use, the p-value method. But I'm going to explain the traditional method for you. Okay, but um, just for you to just know it. But we are not going to apply it for exam sake or for anything. We are not going to apply it. But I'm just going to explain the traditional method for you. Okay, that is the traditional method. And if I'm teaching the statisticians, those who are doing statistics, for them, I teach both for them to know it. But you are just applying the statistics. The most important method in accepting or rejecting the p-value. That is the simplest one. Okay. So I'm going to talk about it before I've seen some hand up. Let me just talk about this before I call Sarah. So for the traditional method, there's something that we refer to as the degree of freedom. So the degree of freedom is the number of observations that can vary. That's what it means. So the degree of freedom is always computed as n minus 1. N minus 1 is equal to df. When we see df, it's the same time the degree of freedom. So that's why we have 8 here. And this degree of freedom is so important. It's so important. That one help you to get your p-values, so on and so forth. I'll show you. So for the traditional method, you always compare your test statistic. Now the 5.17 is the test statistic. For the traditional, please, I'm stressing on this. This is the traditional, and that's not what we are going to use for exam sake. But I just want to know the concept. The traditional method, you compare the test statistic with this value here, which we call the table value, because it comes from a table which is called T distribution table. I have a portion below this slide. I will show you. So you always compare it with the table value, and based on that, you can either accept or reject it. So whenever your test statistic is greater than the table value, then you are going to reject it. And whenever your test statistic is less than, you are going to accept it, which is the now. When I say it, I'm referring to the now. So you see that this one is the opposite of the p-value method that we already know. So this is the reason why I do not want to teach both. Because if you're not careful and you are applying it, you may interchange it and you find yourself wanting. So that is the traditional method. Okay. So now you know what the traditional method does. Okay. So, but I will show you in the next slide, I will show you the how I got this 2.31, and I will also show you how I arrived at the probability value 0.01. It's not a magic that I just choose any probability value. And don't forget that I mentioned that the probability value is always associated with your test statistic. Without a test statistic, you can never get your probability value. Okay. So now, before we conclude, before we draw we take our decision and draw a conclusion. There's a hand up here. Let's listen to that person. Then we move on. Okay. There was a hand up. Sarah.
Sir. Hello, sir.
Please, I'm listening.
Sir, please, I'm sorry for taking us back, but going back to the test statistic, the T where we had X bar over standard deviation multiplied, I don't know if it's multiplication or division by the square root of n. You see that when we calculated, we had
division. You can see it's division. Can't you see that it is below 8? It's division.
So, sir, with the X bar, I had 3, and the standard of deviation, I had 1.73.
No, it's standard deviation. It's not standard of deviation. Please.
Sorry, standard deviation, I had 1.73 divided by the square root of 9. So 1.73 divided by the square root of 9, I came to, I got 5.19. And then sorry, I had the T to be 3 divided by 5.19. So I had T as 0.578. But here I see T to be 5.17. I'm confused.
No, don't get confused. You are not doing it right. The values are the same. So you are not doing it right on your calculator. So you take your time and do it right. Just take your time. Okay. I'm sure you type everything at a go. That's why I said that take your time and then do the downside first, which we refer to as the standard error. You can do the downside first. You see that we are doing that one first. Whatever you get, then you can now go and divide. So take your time and do it. Okay.
So, sir, with the formula as the S bar square root of n is rather division. So it's rather 1.73 divided by root of 9.
Exactly.
Okay. Thank you. Thank you, sir.
Okay. So Bismarck. Bismarck, now let's take our decision. Now that we've computed our test statistic, for exam's sake, let me stress on this. For exam's sake, I always give the probability value and then the alpha. Otherwise, I always give the probability value. Okay, I give the probability value, and then you take your decision and draw your conclusion. But you are likely to calculate the test statistic. You are likely to calculate the test statistic. So Bismarck, now, are you with me, Bismarck?
Yes, please.
Okay, so now we know our probability value is 0.01. Let me draw the chart, the usual chart that we use to accept or reject a null. So now the alpha, which we know alpha to be 0.05, right? 0.05. Yes, now the probability value, which is 0.001. Is it going to be on the left-hand side of alpha or the right-hand side of alpha?
On the left-hand side of alpha.
Good. So what do we have on the left-hand side? Is it R or A? Are we rejecting or accepting? R or A?
We are rejecting.
So that means we have R here, right?
Yes, please.
And then we have A here. So once it falls as the R column, that means we are rejecting the null hypothesis, right?
Yes, please.
Good. So then that is our decision. You've rejected the null hypothesis. Now you can draw your conclusions. So we can now conclude that the drug or the injection did not cause, it's causing a hypotensive effect, right? We are certain because the now will tell that the drug didn't cause any hypotensive effect. Good. And then the alternative, once you've rejected it, that means you are going for the alternative. And what that the alternative tells us? It is telling us that the drug is causing hypotensive effect. So if you are writing it, you can state it like this. Since the p-value 0.01 is less than the alpha 0.05, there is enough evidence that the drug is causing hypotensive effect. Now you see it. So if you report this to the person who tasked you, then he will say, oh, good. There's enough evidence. I hope that's clear. And in fact, these are some of the things that you do in the exam. These things are going to form almost, let me say, about 70% or 80% of your exam questions. The hypothesis testing. As for the mean, the definitions that we learned earlier on, these things are just, but these are going to form most of your questions. Bismarck, is that okay with the conclusion?
Yes, please.
Okay, so ask your colleagues if they have questions, then you answer them. So Bismarck, call them.
Yes,
Call
Lydia,
them.
please, can you bring your question up? Lydia.
Thank you. Bismarck, please, the question is for you.
Okay.
And please, I don't understand why we get the final answer where T8 is equal to the S bar over SE. How we get the 5.17? That's actual answer. The last one, I'm lost here. After getting the 0.
Oh, your line is breaking, Lydia. So
Yeah,
let's
I'm not getting
answer
it
you.
well.
Let's answer you. Okay, Bismarck, let me make it. Let me help you. So T, you've seen that we are saying that T is equal to S bar divided by X over square root of N, right? Is that okay?
Yes, sir.
Good.
Yes, sir.
So if you take X divided by square root of N, is the same thing as this one, SE of the difference. The SE stands for the standard error. And you see that one is here. You can see that SD divided by square root of N. I hope you are getting it.
Yes, sir.
Good. So that is the reason why, please give me something. Let me just tell this person I'm teaching. Okay, so sorry about that. So you see, that is the reason why we are saying that the S bar is divided by SE, because SE is the same thing as the standard deviation by the square root of N, and that's what we have here. I hope you've gotten it.
Yes,
good. So Bismarck, may you wait free. The next question.
Let me sharp I said. Yeah, Stanley.
Oh, just mention one name if you like what I usually do.
That's not, I don't understand the last aspect.
Which
the
last
after the calculation, the last where we are talking about P is equal to 0.01. That aspect I don't understand it.
Okay, so we are drawing a conclusion. If you were here with us last meeting, we said that we always compare the probability value with alpha, and then based on that, we can reject or accept it. Okay, so and then we mentioned that whenever the probability value is greater than the alpha, which is almost 0.05, always, when it is greater than that, we are going to accept the null, and when it's less than that, we reject it. And so that is why Bismarck compared this p-value 0.001 with alpha, which is 0.05. And you can see that this number is less than 0.05. And that is why Bismarck said that we are going to reject the null hypothesis. And now we can now conclude that the drug is causing hypotensive effect. I hope it's clear.
Yes, sir. Yes, sir.
Bismarck, let's call the next person.
Karen.
Bismarck, please, I want you to go over again, starting from like standard deviation. You there quickly go through it for me, okay? From the standard deviation to how we got the final value.
Yes. So with the standard deviation, we have a formula as the square root of the summation of x minus the mean all squared divided by n minus 1. So that's the standard deviation. And we have x to be the differences between the x1 and the x2, which has already inputted above. And we already calculated for the mean, where the mean is the summation of the x divided by n, where you had the differences between the x's, the summation of them to be 27, and our n was 9. So we had the mean to be 27 divided by 9, giving us 3. So with the standard deviation, we already have the mean to be 3. We already know that n is 9. So what we are supposed to find for is the x minus the mean, all squared. And with here, it is x minus mean. You have to find the square of all the x minus the mean. After that, we sum all of them together. So we will take each individual x's, then we subtract the mean from them. So with the first x, we had 2. So we will get 2 minus the mean, which is 3, all squared. Then you continue with the second x, which is 3 minus 3, all squared. You do that throughout all the x's. So after that, the values that you get, sum all of them together, which made us go to the 24. So it's the square root of 24 divided by the n minus 1, where we know that n is 9, giving us 9 minus 1, which is 8. So we have the square root of 24 divided by 8, giving us square root of 3. That is 1.73. So this is how we got the standard deviation. Please, Karen, do you understand?
I do. Please, let's
Okay.
continue.
So from there, then we got our t. We tested it, where the t is the mean divided by the standard, the mean divided by the standard deviation divided by the square root of 9. Sorry, the square root of n. So thank you. So we already know that our mean is 3. So it's 3 divided by our standard deviation. That's we got 1.73 divided by the square root of n, where n is 9. And the denominator, we are seeing that there is a division sign there, but the numerator affects all of the denominator. So we can first work on the 1.73 divided by the square root of 9, where we are getting the square root of 9 to be 3. So we have 3 divided by the 1.73 divided by 3, where we are getting 3 divided by 1.73 divided by 3 gave us 0.576, where we can approximate to 0.58. That's where it's showing currently. So we have 3. Okay.
What is the SE difference?
The SE difference is the same as the standard deviation divided by the square root of n. That
so,
is.
Bismarck, let me help. The SE means standard error. That's what we call standard error. And it's the same thing as SD divided by square root of n. So instead of saying that SD divided by square root of n, I can see that the mean divided by the standard error.
Okay. I think that's where I got lost.
And we want my Bismarck abresa. Okay, simple.
No, because for me, after doing it to, so let me explain. After doing it to the standard deviation, I just, you see where the t is, where we are finding the t is equal to the mean divided by the standard deviation over the n, square root of the n. So right after that, I just put it in like that.
Okay, so now you've understood it, right?
Yes, I did.
Okay, good. So let's move on. I want to justify my p-value, and then so that you appreciate it. Okay, please, I want to justify it. Give me time. Okay, Bismarck, I think the next person is Emmanuel Oti.
Yeah, Emmanuel.
Hello, sir. Yes, sir.
Hello, sir.
Sir, I wanted to know where we got our p-value from, and also what does the T stand for, and what are we using the T value for?
So the T is the test statistic, and it is the T test statistic that is going to help us to find our p-value, which I'm going to illustrate on that. So let's call the next person now.
Yeah. And
yes.
also the p-value. I said, where did we get the p-value?
I said I'm going to illustrate it.
Yes, sir. Thank you, sir.
Good. Yes, Dorcas.
Sir, mine is with the 2 points. It's down the conclusion. It's where we got the 2 points. Yes, please.
Yeah, that one I've explained it. I told that is what we call the table value, and that's the traditional method. That's why I was stressing that. Please and please, I'm just telling you that one is not. That one is not. That's not what we are doing. That's not what we are going to use for exam's sake. We are using the p-value method. So that's what I said on that. But I'll show you how I also got the 2.31. That is a traditional method. Okay.
Callistus.
Hurry up, please. Callistus, please, you are not talking.
This back, I want to on using the sample standard deviation formula and not the population standard deviation formula. Or what we are dealing with now is the sample standard deviation formula. So how did you arrive at this particular formula? What informed the decision to adapt the standard deviation formula?
Okay, so you see that the statement in there, it was a sample that they are dealing with.
Hello?
Did you get it? I said that you can see in the statement that we are dealing with a sample. We are not dealing with the population. And that is the reason why I always mention that if you can recall, I said that this one, the sample size should be always less than 30. So the T distribution always deal with sample. This one we are dealing with the sample.
Okay.
That's why we use the sample standard deviation.
Okay.
And even that, okay, it's okay. I just don't want you. It's okay. It's okay. Let's continue, Callistus. It's okay.
All right.
Okay. So my sisters and brothers, now I'm going to show you how we got the 2.31 and then the probability value. Okay. 2.31 and the probability value. Now, Kubitrice, the last person before we move on. Now, unmute yourself.
Yes, sir. So I just want to ask, so if the answer that we got as 5.17, it's 0.001. So does it mean we should accept it or reject it? Thank you.
No. We are accepting and rejecting based on the probability value. Okay, but if you are doing the traditional method, that's where you compare the test statistics. But that's not what we are doing. We are not using that one. We are using the probability value, please. So if the 0.01 that you said, if it's probability value there, then that one, it's less than the alpha, then you reject it. Okay, it is the probability value. Please take note of it. So now let me zoom out. Okay. Bismarck, can you see it? You are using the two side.
Yes.
Can you see it?
Yes, please.
So this is what we call the T distribution table. The T distribution table. And this one, if you go online right now and you search for T distribution, you get this. But this is just a portion. That one, you get the degree of freedom to be up to 29. You get it up to 29. And these are the respective alpha values. If you remember, I said that the degree of freedom are the number of observations that can vary. And I said that one is always n-1. When you are dealing with T distribution, it's n-1. So if you look at our test, we had what? 8 to be our degree of freedom. 8. So what you do is, I'm now going to justify the 2.31 first. Then after that, I'll show you the probability value. So what you do is, you look out for your degree of freedom. And our degree of freedom is what? 8. Then you go to the alpha value, which is the same time probability value. The alpha value, see there. We are testing it at alpha of 0.05. We have 0.05 there. So then you can draw a vertical line or a vertical line. Then you come to the degree of freedom, you draw a horizontal line. So where they intersect, the value there is what we call the table value. And this is the reason why in your notes, you can see 2.31, the table value. And so this is the traditional method. Those who are using the traditional method will compare the 5.17, the test statistic, with this value 2.31. You see that one. Then you can now tell me that since the test statistic 5.17 is greater than 2.31, that one we are going to reject it. That is the traditional method, and that's not what we are doing. That is the traditional. So now let's come back to the p-value. The p-value. Okay. So now let's justify the p-value. Good. So for the p-value, what you do is you also start from the degree of freedom again. So the degree of freedom is 8. At the degree of freedom, you have to check horizontally. You have to check the values among the values on that line. Which of them is the closest value to your test statistic? And our test statistic is what? 5.17. So what is the closest value? Bismarck, can you tell me? Based on that value.
5.04.
Good.
Or 5.
Good.
Okay.
So this is the closest. 5.04. If you go and pay 5.62, you are way be above 5.17.
Yeah.
So this is the closest value. So at the closest value, then you go and pay the respective alpha value or the probability value there. So you see that we have the probability value to what? 0.01. And so now you can now draw your conclusion. I hope you are getting it. And that is why I have 0.01 there. But normally, for exam's sake, I don't give the table for students to go and read. The reason why I do that is in real life, this thing, you use software to do it. And the software can give you the probability values, the test statistic, and even the table values to give it to you. Do you get it? So that's why for me, I don't give the table for students to go and read and tell me the probability values in there. Do you get it? But if students want it that way, I can add the table to questions, then you go and read it as I just illustrated. Okay, so let me just go over the probability value again. Let me just go over how I arrive at it. So you need to first know your degree of freedom. And the degree of freedom for the t-test is always, the dependent t-test is always n minus 1. So n minus 1 will give us 8 for our test. We had a sample of 9, we subtracted 1, we had 8. So on the degree of freedom, you look out for the number which is the closest to your test statistic. And our test statistic, we had 5.17. So the 5.17, what is the closest value? And Bismarck rightly said 5.04. So the moment you get your closest value, then you go and look out for the respective p-value there. And that is 0.001. And once you identify your 0.01, you are good to go. That is your probability value. And then now you can compare it with alpha and take your decision that you are rejecting it and draw your conclusion. Okay. So that is it. So it's not a matter of because for free, these figures. No. So as I said, normally I don't give the table for students to read the p-values. I give her the p-value for them. I will provide a p-value. And then based on that, you can draw your decision. Okay, please, any questions so far? And please, I'm begging you, don't limit yourself to only what once I've teaching you that you can get questions online, try your hands on it, and that will be fine. Okay, Rebecca.
Sir, good morning.
Good morning.
Sir, please, after getting the p-value, which is the 0.01, and then our final answer that we had was the 5.17, which is greater than the 0.01 or the p-value. Does that mean I don't understand the conclusion you drew, because from last week's discussion, you said when the p is greater than 0.5, it means there is a significant change of value. And it is used when the number, the sample size is less than 30%. So
I think 60%. When the sample size is less than 30. That's when you use it.
Yes. So now that we had 5.2 or 5.17, which is greater than the 0.01.
You are putting round shapes in square holes.
I'm confused about drawing the conclusion
No.
there.
Listen and listen very well. It seems that you guys don't listen when I talk. I said that we compare the p-value with alpha, but you are comparing the test statistic with alpha. These things are two different things.
Oh, okay.
Do you get it? So you compare the p-value, which is 0.01, with alpha 0.05. And from there, then if it is greater, you are going to accept the null. If it is less than, you are going to reject it. I hope it's clear now.
Please come
Please,
again.
can I help?
Okay.
Yes. So, Rebecca, what we are using the t value for is to find our p-value. That's the essence of the t value. So going through, we got our p-value to be 0.001, and the p-value will be used to compare. We use the p-value to compare the alpha, which is 0.05. So what you already knew was that you compare the p-value to the alpha, which is 0.05. From there, you deduce whether we are rejecting or we are accepting. But what we initially went to finding the t-value was to find the p-value, which we didn't know already. Now we've gotten the way to find the p-value. Thank you.
Thank you too.
Okay.
Any other?
Yeah. Rashida.
Please, I wanted to ask, without for the p-value that we use the table to find, without the table, how are you going to find the p-value, if I may ask?
You can't do without the table.
Pardon?
You can't do without the table.
Oh, okay. Thank you.
But if you people in the exam, you want me to give the table, I can give it to you.
And then please give us the table.
No, sir, just give us the p-value.
Give me the table. Sir, please give us table.
Please give us table to be fun.
Don't give us table. Give us the figure.
We don't want any table.
She
We don't want
doesn't
any
understand.
table.
That's why
It's
she's
okay,
saying give us the
please.
table.
Last question.
You don't like the table. Then table, Nino. Table on the bed.
Hey, please.
Please.
Stephen, please hurry up. My time is almost up. Please. I told you guys I'll leave this class. Please, let's listen to them. Bismarck, please, you can unmute yourself. Bismarck.
Stephen.
Yes, you can unmute yourself.
Stephen.
There. Hello.
Yes.
Yes, please.
Okay, sir. Thank you. The lady who just asked the question, I think she asked my question, but I wanted to also find out. Bismarck was saying that the p-value is not given. I mean, the alpha. We compare the alpha and the p-value to now accept or reject. So you said without the table, you can't find the p-value. So in that case, is it going to be provided for us, or it's either you give us the
My brother,
p-value?
were you in the class?
Say, yeah, but my network was breaking in a way.
Okay, that's fine. So that's why people were even fighting the other lady. I told you guys that normally for exam sake, I provide the p-values. And then you compute your test statistic.
Regina.
So,
okay.
Afan said you can lower your
Yes, sir. Please. So if I may ask, it means that the value that you get for your p-value will depend on your t-value that you get. I want to clarify this for myself.
Will depend on what?
Your t-value, the t that you get.
Exactly.
Okay, thank you.
Exactly.
Regina, please lower your hand for us. Francisca.
Hello, sir. Good morning. Please
Good
come
morning.
again with how to accept and reject the test for me, okay? Thank you. Come again with how to accept or reject the test for me. Thank you.
Okay, when your probability value is greater than the alpha, you are going to accept it. When it is less than the alpha, you are going to reject it. Bismarck, do you still have questions?
No, please.
Okay, that's fine. Okay, so my sisters and brothers, please, if you don't have any question, I'm ending the class. So, God willing, next week. But I'm pleading with you that you take your time to revise on or read. It's not a matter of revise. Read on the chi-square test. Okay, the chi-square test of dependent. I've sent a lecture notes to your class rep and a video to that effect. So you can watch that one, and God willing, next week I'll tackle that one. And then when we are done with that, I'll talk about correlation. So after I'm done with correlation, then we are good to go. Okay, then we can go and then write your exam. But what I'll do is normally I let you do some online exam, the so-called missile. And that one, please, that I intentionally do it at the tail of this semester. So that at least if you are owing, by then I believe God that you will be able to pay the portion that permits you to go to the V class. Okay. So please do your best to do that. Okay. So in the next 2 weeks, if we meet 2 times, that should be fine. Because I think next week I'll talk about the chi-square test. The following week I talk about correlation, and I think that's fine for exam sake. I think that course is okay. Okay, so please take care of yourselves and God be with us all.
Okay.
God willing, we'll meet next week. Is that okay? I think I can leave, right?
Yes, sir. Have a lovely day.
Thank you, sir.
Okay, God be with you.
God bless you for thinking about us. Thank you.
Thank you.
God bless you.
Bye-bye.
Bye.
Hey, Asamunye.
Please, don't answer my
Brother
question.
McDonald.
Sunday,
McDonald, please.